I can't give you all the opportunities in life, man. Everybody else. Here we go. There we go. We're good to go. So let's start talking about, guys, graphing functions. Oh, would you like to know the answer to that one? I'm going to get into the answer, dude. I'll totally get into that answer. Not, not right this second. Well, let's cut the dialogue out and let's have a monologue of Mr. Gillespie talking for a little bit. And what I want to talk to you guys about is this cool function, and it is called f of x, and f of x, oh, doesn't equal f of x. F of x equals half of x plus 3. Wow, that's pretty cool. So when f of x equals half of x plus 3, what could we do with it? Well, I'm already given this graph, guys. And what the graph is telling me here is, hey, we've got this line, and this line is a red line, by the way, because red's a good color. And what it's telling me, I'm going to use this too. What I'm going to say is, hey, do 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 do. You can't really see that, can you? So I need to change the color on this. Make it thicker. Cool. So here's our line, but it's really going through this point here. It's really going through. Oh, and there. So those are our points. And what I need to know, what I'm really asked here, is to find f of x when what I really wanted to do, I gave you guys some other coordinates to locate, and those coordinates should have given you when y equals 0, you should have found that it was equal to negative 6, I believe, 2, 4. Yeah, it should have given you negative 6. And when x equals 0, you should have had positive 3. And if you did and got that, that would have been correct. So what I want to know, though, is what happens when y is, or when x is equal to negative 4. So the way to do this is I could actually go to this graph here, guys. I could go to the graph because it was given to us, and I could look at negative 4. I go 1, 2, 3, 4. Oh, well, y looks to be close to positive 1 right here. Y looks to be close to positive 1, but I can't just take it as a fact. I can't really say, well, yeah, that's true because I see it on the graph. What I got to do is check it on this function here, and what I got to do is say, hey, when f, well, you can't see that, so let's get our yellow back. F of x, or when f of negative 4, what's f of negative 4? So that's what we're going to solve, and I'm going to scroll down the screen just so we have more room. Oh, Mr. Gillespie. F of negative 4 equals, well, it equals half of, oops, negative 4 and plus 3. Well, half of negative 4 is actually equal to negative 2 plus 3. Well, negative 2 plus 3 is equal to positive 1. So, yeah, if I count back for negative 1, negative 2, negative 3, negative 4, hey, y is positive 1. So f of negative 4, when f of x is equal to negative 4, y equals 1. Or f of x, or f of negative 4 actually equals 1. Cool stuff.
How did you solve when you had f of x or y is 0?
Yeah, when y was 0. That was kind of a tricky one because we really haven't covered that. Just remember, here's my question for you guys. So what I'm saying here is I gave you two other values. I just wanted you to work and play around and see if you could get it. I said, hey, f, oh, wait, let's do this. Let's do xy table here, okay? And I'm going to create some ordered pairs. And what I want to do here is say, hey, here's my chart. And Sarah, my chart is x is 0 and y is 0. Okay. What's up, girl? You gotta go? Got it. Take care. Okay, bye-bye. So when x is 0, what I'm going to do is say, hey, f of x, or f of 0, equals, was it half? Half of 0 plus 3. Well, half of 0 is really 0, so what you really get is positive 3. And we'll go back to the chart and check that out. When x is 0 right here, what's y? Positive 3. Yeah, it checks out. Okay, cool. So our function, the actual function up top, yeah, it's holding true so far. So let's see when y is 0. So what does f of x represent again? What's another, if we went to our table? Yeah, it's our dependent variable. So I'm just going to say 0 equals half of x plus 3. Okay, so the first thing I've got to do here is subtract 3 from this side. So now I'm subtracting 3 from both sides. So now I got negative 3 equals half of x. Well, how do I get rid of the positive half here? Multiply it by its reciprocal, which would be 2 over 1. What? So I'm going to multiply by 2 over 1. The reciprocal of 1/2 is 2 over 1. That's how you get rid of the fractions. Multiply by the reciprocal. So now I got 2 over 1 on this side, multiply both sides, and 2 times negative 3 is negative 6 equals x, and these guys canceled out. So now let's check that out. So when y is 0, let's look on our chart here. If it works out, I should have negative 6 for my x. So we go back to the chart and say, hey, y is 0, 1, negative 1, negative 1, negative 2, negative 3, negative 4, negative 5. Hey, negative 6. Cool beans. It worked. Let's move on to the next one. Jacob, what's your question, dude?
Wouldn't 2 over 1 be 2?
2 over 1 is 2, sure.
Yeah.
So multiply. I'm just saying multiply by the reciprocal of a half. The reciprocal of a half is 2 over 1 or 2, okay?
So that's what it says to have the question from you.
Could be 1, yeah.
Would you have to write 2 over 1 or would you write 2?
What do you think? Wait, guys, this is a great question. Jacob is a genius, always has these bright questions, but sometimes he asks me questions I feel like his brain he could answer with himself. So Jacob asked me, hey, back with this last problem, he said, hey, you know what, Mr. Gillespie, I'm a genius. He didn't say that, but I just knew that he was. And so what he said is, instead of writing 2 over 1, could I just write 2? Yeah, but you got to be careful, don't you? Because you got to remember not to trick your brain to thinking that 2 is a different part of the equation after you write it. So some people forget that they're using 2 to get rid of this half. So that's what I'm saying. Write the reciprocal. If you don't need it, don't put it in because you'll solve the problem correctly, won't you? How did you do that? Oh, rubber band. I was impressed. I was going to say, is he a magician too? Okay. Let's go to our next one. Just roll with it, right, Trevor? Just go with it. Just go with it. All right, guys, here is our next problem, and I need to pull something up before we actually get rolling with this one. So you get a 1-minute talking break. You can read if you want, do what you need. 1 minute, 1 minute. Might even be less than a minute if I get it up quick.
Hey, Jacob, don't be like that, man. Don't.
Yep. No, hey guys, this should be going in your notes, man.
I know.
This should really be going. Peyton, what are you doing, buddy?
I don't have a whiteboard. I was listening. I knew the answer.
You did?
Yeah.
Oh,
So did
wow.
I.
Okay,
I
guys.
got y equals 3.
Back on track. Back on track. Here's the next statement that I'm going to read. I'm just going to read it to you guys. I'm not going to throw it up on the screen. So listen or you'll miss out. Listen. The function y equals 7.5x. describes the number of inches. Y, a beetle, Y the variable, describes the number of inches a beetle can travel in X seconds. So 7.5, Y equals 7.5X. That's the number of inches a beetle can travel in X amount of seconds. So they want you to graph the function, use the graph to estimate how many inches a beetle can travel in 2.5 seconds. What's up?
Do you have another whiteboard? Just because, I don't know, I'm missing a whiteboard. The person behind me also doesn't have a whiteboard.
Man, oh man, you're just having one up there. Yeah, I do, but I'm not going to play around getting one right now. I'm going to keep rolling with it. So you should pull out some paper and just take some notes. Okay, so now here we are. These are the facts that we were given. This is the equation that we get for the beetle's travel. Y equals 7.5x. And Y is the amount of inches that a beetle travels, and X is the amount of seconds that the beetle's traveling for. So they want us to graph and find or estimate the amount of inches a beetle can travel in 2.5 seconds. Okay, cool stuff. So what's that? No, they want you to find how far a beetle would travel in 2.5 seconds. So we're going to create this graph. You'll see in a second. It'll totally make sense. So we got X here, and we need to take some thought into the problem that I just read. I'm just going to tell y'all it for now. And, huh? Guys, good man, good man. Listen up.
Oh.
No, X equals 7.5.
No. Oh my God.
Look what you just did, Trevor. Your question and you asking questions, I can't believe you asking questions, caused an uprising in our class. A revolution. Okay, here we go. Guys, we got time on the bottom. Time's going to represent our independent variable. It doesn't matter how long the beetle travels. The beetle can travel for as long as he wants. So that if time is the x-axis, what would be the y-axis? What's the independent variable? Length, or let's call it distance. But we've got to be very careful here, guys. When we label these, the time has got to be in seconds, the units, and the distance is actually inches. You must make sure to label the units. From here, what I'm going to give you, choose a new color. Yeah. Okay. So what we know, guys, what we know is that the beetle can travel at a rate of 7.5 inches per second. We know that much. 7.5. What's that? No, the 7.5 right here describes how fast in 1 second. Yeah, x equals 2.5 seconds. So the graph that we're going to create has to look something like this. The graph that we're going to create has to look something like, get this down. Well, you know what? Before I even throw a graph on there, I've got to label numbers, don't I? So 1 second. Let's say, hey, this is going to be 1. That's not bright enough. It's too dark. This is 1, 2, 3, 4. Each line represents a new second, okay? And this is going to be on the website. It'll be easier to see. But hey, let's say that every bar here represents about 6 inches. 6, 8. It's just a nice, easy unit to use. That's supposed to be 12, not 8. 6, 12, 18, 24, 30, and 36. Cool. So I got my units, and now I'm going to actually graph it because it will make sense in a second. I already know what this graph looks like, and I'm giving it to you. So we know that 1 second is just about 7.5 seconds. And from there, let's ask, well, what would it be around 4 seconds? The big question is, where would it be around 4 seconds? Huh? Yeah, it's about 30, and in fact, it is 30. It is 30. And I could do this by saying, hey, if x was 4 for 4 seconds, y equals, get a bright color, y equals 7.5 times 4. Hey, 7.5 times 4. Well, what's 7.5 times 2? Double it. 7.5 doubled is 15. So a quadrupled is 30. Okay. Guys, I'm just looking at this chart. I'm saying if x were 4 seconds, all I got to do is say, hey, where's it at? It's at 30. And I'm proving it by plugging 4 into the equation. I'm checking it. Now, the next step is to say, hey, what if y equals 7.5 times 2.5 seconds? Well, they gave us this graph right here. So let's look at this before we even actually calculate it. And what you're going to do here is say, hey, 1 second, 2 seconds. So here's 2 seconds, here's 3 seconds. Well, x has got to be at 2.5 seconds. It's halfway between. So all I'm going to do is scroll up and see where it's at halfway between, and it's right about here, which is just a little bit above 18 seconds. Okay, so it's about 18 seconds, a little bit more than 18 seconds. And if now you calculated 7.5 times 2.5, hey, that beetle travels at about 18.75 inches per 2.5 seconds, right? Okay, so that's the actual solution, but you just needed to estimate it. You didn't actually need to calculate it out, and the way you estimated was by looking at the graph itself. Yes? I'm not going to, and what I'm going to do is have this posted online, so you can always go to the website and come back to it. Okay? You can always find it on my website. I'm moving forward to the next example. And the question, you'll be able to read the question online. Okay? All right. Now, our next problem that we got to get to. Huh? I don't know what you are talking about.
I was talking about that. So it's not like, I don't know, Jake.
I don't know what you're talking about. I'm going to move forward, guys. Okay. So here's the next problem that we're going to work with. We are given the function. Let me pull this up again. So I'm given this function, guys. And this is the function. It is, hey, x squared. This is what y'all need. X squared is plus 1 equals y. Well, you know what? I don't want to read it like that. I want to set y up first. So I'm going to say y equals x squared plus 1. Cool. So from here, what they want me to do is create some ordered pairs and actually graph this equation right here. So yeah, I'm going to do that. I'm going to say, hey, y equals x squared plus 1. Well, let's actually graph this. So I'm going to have to create me a table here. And then, who's lost on this one already? Nope, I've just given you that equation there. So they're saying, hey, take this equation right here. Take this equation, right? And go ahead and graph it. Well, I can't graph it because I don't have any ordered pairs, do I? So what I've got to do is create some. All right? So yeah, making our own. In fact, you can make any values you want. I'll give you some that I'm going to use, and then you can use whatever you want. So I'm going to use the equation y equals x squared plus 1. Uh-oh. And then let's say x and y. These are going to be my ordered pairs. And let's at least get 5 points. I want to do that. Cool. The 5 points I'm going to create. Okay, so let's say that x equals -2, -1. You don't have to use these. You can use what you want. 0, I'm just using some simple ones. And now I'm going to say, hey, y equals -2 squared plus 1. Y equals -1 squared plus 1. Y equals 0 squared plus 1. Y equals 1 squared plus 1. And y equals 2 squared plus 1. Cool. So what could these actually be? Well, 2 squared plus 1 is actually equal to, well, 2 squared is 4 plus 1. Well, that's 5. Okay, so 5 is my first value of y. -2, thank you. -2 squared is still 4 plus 1. 4 plus 1.
Wait, what is found in parentheses?
Thank you. Thank you. I should have put it in parentheses. I was writing so fast I forgot to. So I was writing fast. And yeah, these should all be in parentheses. Always need these in parentheses here. So there we go. And I'm going to leave these ones out, but they should be in parentheses. You're absolutely right. Thank you for holding me accountable. So now -1 squared is 1 plus 1 is 2. So this value is 2. And now 0 squared, 0 plus 1 is 1. 1 squared plus 1 is 2, 2, yeah. And 2 squared, 4, plus 1 is 5. Cool. Okay. So now let's write my ordered pairs. -2, comma 5. -1, comma 2. 0, comma 1. 1, comma 2. 2, comma 5. What's up, dude?
On the test, so like, say you give us a function like this, would it be okay if you just like set up a table and just put x and y, and then just did mental math and just set up like
Yeah, but if you miss it, guess how many points I'm taking off?
No, I know, but it looks like this. So you just like have the x and then
Sure, but if you miss it, guess how many points I'm taking off? That's not enough work to get minimal amount of points taken off if you get the problem wrong, right? You make one small mistake, and that graph looks wrong, you're going to miss a lot of points. So it's up to you. Okay, so let's go ahead and graph these ordered pairs here. And I know this chart's small, so I'll work with you on it. And let's go and use some spray paint here, guys. We don't get to spray paint enough in life. There we go. So now, making sure my paint bottle's ready and working. I had to shake it up some. Okay, so -2. Let's go -2, 1, 2, and up 5. 1, 2, 3, 4, 5. Come here. And it's just my screen. -1 and 2, so -1 move up 2. Cool. And my next one is 0 up 1, so about here. And my next one is 1 plus 1 comma 2, so that's right here. And then finally, I have 2 up 5, which is right here. Cool. So look, guys, if I were to actually draw a line through this, it actually looks like a U. Oh, that's a bad line. Ah. Let's try this again. See if I can get it down. There we go. So forgive my horrible U here, but that's supposed to be our U right here. Right? So that's our U, and we've got a U shape with this graph. And later you're going to learn, hey, these U shapes are called parabolas. But right now, just know that this is an actual U shape. That's all you got to know right now. So let's move forward from here. We've just graphed our equation. We'll move on to another piece. Yes, sir. You may go. You may go. Hello. What's up?
when you do the parabolas, can't you like you had 5 points on there. If we did a straight line between every point, wouldn't that not be correct?
Hmm?
Never mind. I just like, okay, fine.
Hey guys, let's work one more. So we did one where they didn't give us the domain, but what if they actually gave us the domain? It's probably a little bit easier because the domain stands for what?
The high and low.
The domain does not stand for the high and low. The domain stands for all x values, all independent values. So we're going to be given the domain. Guys, you weren't given the domain before. That's tougher to do. If you don't have the domain, you've got to create your own. That's tough to do if you don't see it. But now they are actually crazy enough to just give us the domain. Makes life a little bit simpler for us. Let's just make sure that you know where to place them. Let's say that I give you the value or the equation x minus 3y equals 12. Cool, so x minus 3y equals 12, but they're going to give us the domain, which is the domain. Give me your braces here. Say they are giving us the values and want us to graph when x equals 3, 0, 3, and 6. Hey, and while we're at it, let's actually be crazy enough to find out if this is actually, no, let's not. So x minus 3y equals 12. So when x minus 3y, guys, I'm obviously going to create a table here because I've got more than one value to find. So just make a table like before. I want to do that. Cool. So, hey, again, my xy, and x minus 3y equals 12. So let's go ahead and solve these for when we have negative 3 for x, 0, 3, and 6 for x. Well, the first one I'm going to do is negative 3 minus 3y equals 12. So what would that be? Well, the first thing I need to do is do this, guys. I've got to say, hey, give me a second here, guys. Negative 3. Well, the first thing that I want to do here, how do I get rid of negative 3 on this side? Let's divide or just multiply by 1/3. And I'm going to get rid of negative. Why am I getting rid of negative 3? Give me a second here. Oh, ha ha. Do not write that down, guys. I'm sorry. I jumped way off bounds here. Guys, what do I want to do to make life easier for me instead of solving this way? Before you even set up this equation, what do you think, kiddo? Well, who's got their hand up? I'm asking, what do you think? Yeah, let's solve for y first. So let's solve for y. I'm going to solve for y way down here. Cool. It makes way more sense to do that, and you can see I struggled for a second without doing it. So let's make sure to do it. So now I've got x minus 3y equals 12. Well, let's get x on the other side. So now I have to subtract x on both sides here. So now I have negative 3y equals, let's start with negative, I'm going to put x first. Negative x plus 12. Cool. Now, let's get rid of, I want to get y by itself, so I'm going to get rid of 3y here, negative 3, I mean, by dividing by not only negative 3 on this part of the equation, but I've got two terms here. I've got to do it to both terms. I know, isn't that crazy when it does that? Okay, so I've got to divide negative x and positive 12 by negative 3. So I end up with y equals, well, negative 3, negative x over negative 3 plus 12 over negative 3. Well, are we finished yet? Because is this fraction simplified? No, I'm taking it step by step. Day by day, we're going to make life a better way. Okay, anyway, y equals, well, it equals, let's say, hey, it equals actually 1/3 x, or just x over 3, plus -4. So I could really say what? -4, absolutely. -4. So that's what I have as my value that I'm going to put up top. And I'll do this. Let's copy that guy. Huh? Because I'm awesome. And, yeah. How are we on time, guys? I think we'll do this. We'll get it down. Here we go. Well, what I want to do, and it's not working here, I'm just going to move forward. I'm going to put the equation to the right here. That's the equation that I just created, right? So that's the equation that should be in this orange blob. And that's the equation that I'm going to put in each cell down here. Not right now. So I'm going to say this. Hey, guys. Y equals 1/3 times -3 minus 4. Okay. And let's just write out all the equations real quick. Y equals 1/3 times 0 minus 4. Y equals 1/3 times 3 minus 4, Erica. Y equals 1/3 times 6 minus 4. Cool. So now I'm actually going to solve all of these and put my ordered pairs in here. Well, when when x equals -3, y is going to equal, if I solve this out, well, hey, these two actually cancel to give me 1/3, and -3 actually give me, well, -1. -1 minus 4 actually give me -5. So I have -3 comma -5. My next step is, well, when x is 0, I've got 0 minus 4. So I have 0 comma -4. My next example, x is 3. So 3 times 1/3, well, that equals +1 minus 4, which is -3. So I have 3 comma -3. And finally, 1/3 times 6. Well, what's 1/3 times 6? It's really 6 over 3, so it's going to break down to 2 over 1 minus 4, which is -2. So now I've got 6, -2. Cool. All right, from here, these values, I want to go ahead and graph them. So let's go ahead and graph these values. Cool. And these values, -3, -5, so -3, 1, -1, 2, 3, -5, 3, 4, and 5, so right here. And then 0, -4, 0, -4. Then I've got 3, -3, 1, 2, 3, 1, 2, 3. Then I've got 6, -2, 6. Do, 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 do. Cool, and I should be able to just draw a line straight through this one, which I can. Awesome. So that is how you can create graphs from functions, actually visualize, because remember, guys, sometimes lists of numbers or just seeing equations doesn't really give us a good representation of what we're talking about. Sometimes it helps to create a visual like a graph. And those graphs actually can help you make meaning of the numbers or lists that you're working with. Hey guys, tonight's homework is listed on the board. These videos, I know we ran through them fast today, but these videos will be posted on my website. If you've got questions, go and watch the videos. Just skim through what you need to watch.